Okay, so we have already discussed about the array processor. Now, another processor that is used is the superscalar processor. So, already in the VLAW processor and the vector processor, then array processor, we have seen that all of these processor work on the basically array of data, large array of data. Some works on the array of data. That means large amount of data will be there. But in superscalar processor is what superscalar refers to a machine that designed to improve the performance of the execution of the scalar instruction. So basically a scalar processor is what? Scalar processor refers to a machine that is designed to improve the performance for execution of the scalar instruction. Scalar instruction means single data. It will work on the single data. So to improve the performance of the execution of the scalar instruction or single data, the superscalar machine is used. Superscalar is basically such a processor which performs operation on the scalar quantity, means work on the single data. Like, let's say there is variable max equal to 2, or store or 2 data addition. Let's say only 2 values are present there, and between them we have to perform the addition operation. So that is what? Only a single data, it is working the addition, subtraction, multiply, etc. But vector processor and the array processor is working over the array of data. So this is the difference. That superscalar processor or scalar processor, we can say this scalar processor also, it works on the scalar instruction, whereas vector processor and array processor work on the vector instruction. Vector instructions means multiple data or the array of data, and it is only the single data or the single instruction. Superscalar means faster than the scalar processor also. We say that as a superscalar processor, faster than the scalar processor, that we call as the superscalar processor. Superscalar processor is basically in the contrast to the intent of the vector processor, because in most application the bulk of the operations are on the scalar quantities. Now basically this is used widely this superscalar is basically used. Now vector processing, and in the example of the vector processing, I have said that when the large amount of data is needed, in that case the vector processing is required. Now when that large amount of data should be required, now if you remember, this large amount of data we require during the long range weather forecasting, petroleum exploration, medical diagnosis. In that cases the large amount of data is required, but always we do not have this large amount of data should be required always, because in normal we have the intended, we have most applications, and there that most applications the bulk of operations are present, and they are of the scalar quantities. They are basically of the scalar quantities. Only in some cases, that is this aerodynamic space simulation, image processing, artificial intelligence, array of data is needed, array of data or the large data is needed. In that cases, the vector processing is we done. But in real life, most applications we have that bulk of operations are present of the scalar quantities. So that's why we have to use the superscalar processor or the scalar processor in that time. So vector processor is not needed there. So if we use scalar processor here, then the number of instruction per unit time will be less if we use the scalar processor. But if we use the superscalar processor, then the number of instruction which will be executed per unit time or the throughput is more. That is the difference between scalar and superscalar. That means if we say fast, let's say we say fast or super fast, that is the difference. That means it is more faster than that. So scalar processor and superscalar processor both are same. They work on the scalar quantities or the scalar instruction. But superscalar is much more faster than the scalar. So per unit execution of an instruction, or we can say the throughput or output, the output we get by per unit execution of an instruction in the scalar, it is much more in the superscalar than the our what is in the scalar. It is much more in the superscalar. The superscalar per unit execution of instruction will be much more than the scalar processor. So this is the difference. This is the difference of the superscalar processor and the scalar processor. And basically in our daily life, the most instruction which we have, the most application that works on the operations of this scalar quantities only. So that's why vector processor is not needed always. In some cases we require that, but mainly this superscalar or the scalar processor we used. And in superscalar processor, instruction execute independently in different pipeline. So in superscalar processor, the instructions will be executed independently. They are not dependent on others. Their working will be independently and in the different pipeline. So that means the throughput or the output will be increased. So this output executions will be increased, the throughput will be increased. And in superscalar processor, there is multiple pipeline present. This in superscalar processor, basically what happens that in the pipeline concept, if you remember that we have discussed the execution of an instruction, we require 5 stages: instruction fetch, instruction decode, then our execute, then to our memory write, then we will store that into the memory. This is the thing which we have. Total 5 stages is present there. Now, same concept, pipelining concept is present in the superscalar processor, and there multiple pipeline is present. Multiple pipeline is present there, and this multiple pipeline, multiple instruction will be executed, because let's say there is a processor present and this processor has multiple pipeline. So in this multiple pipeline, multiple instructions should be executed. So that means this multiple instructions will be executed by multiple pipeline simultaneously. So if that happens, then the number of instruction per executed time will be increased, because a processor is present and it has multiple pipeline, and this multiple pipeline are doing executing multiple instruction. So that means what? Per unit time, multiple instructions will be executed. So if multiple instruction executed per unit time, then that is it will be throughput will be increased. So one is related to another, one is related to another. So if that happens, that means number of instruction executed per time will be increased, because in that means if it is increased, then the output will be increased, throughput will be increased. So that's why this is said that if in superscalar processor there is multiple pipeline present, this multiple pipeline will execute multiple instruction simultaneously. So that means what? Instruction number will be increased per unit time. So if per unit time instruction number is increased, then we can say the throughput will be increased. So the throughput will be increases in the superscalar processor. And a superscalar processor is a CPU that implements a form of parallelism called instruction level parallelism within a single processor. Now, this is what instruction level parallelism, if you remember what we have done, that there will be a CPU, we divided that CPUs in the, we have multiple CPUs present, and this, if we have a large program present, we divide that program and give to each of the CPUs to execute that. So that means, let's say we have 4 CPUs present. So that means we divide that our large program into 4 parts, and each part we give for each CPU, and they will be executed. So only in 1 unit of time the 4 our total program get executed. This is the our parallelism concept. Now this parallelism concept or this parallelism implementation in happens within a single processor. Within a single processor, this implementation happens, and that is done by the superscalar processor. That is done by the superscalar processor. That is why it is said that the superscalar processor is a CPU that implements the form of parallelism called instruction level parallelism within a single processor. So within a single processor, this is done. This execution is done. So it will implement that. Now, superscalar processor executes multiple independent instruction in parallel. A common instruction like arithmetic, load or store, etc. can be initiated simultaneously and executed independently. So simultaneously fetch and executed. So there we have already said that the instructions multiple pipeline are present. Multiple pipeline means multiple instruction will get executed. Multiple instruction get executed means what? Number of instruction per unit time will get increased. So if it is increased, the throughput will get increased. So that is why the instructions, the common instruction which is present like arithmetic, load, store, etc., that will be initiated simultaneously for different and executed, but it will execute independently. So from here we can say that all of the fetched are simultaneously and it is executed. And this architecture, this superscalar processing is basically used by the RISC. Now remember, reduced instruction set computer, that RISC basically use this type of superscalar processor. This is mainly used in the RISC, reduced instruction set computer. And the main principle from here of the superscalar approach, we can say that the main principle of the superscalar approach is that it executes the instructions independently in different instruction pipelining, which leads to the parallel processing. That means the main principle of the superscalar approach is that it executes instructions independently, because multiple pipeline is present, so multiple instructions will be executed, and this will be executed independently in different instruction pipeline. That is the basically thing, that multiple instruction and it will be executed in multiple pipeline. So that's why these instructions will be executed independently in different instruction pipeline. Now that means what? If multiple instruction get executed in the multiple pipeline. That means parallel processing. It is called the parallel processing. This is parallelly all the instructions are getting executed. All the instructions are executed in parallel. So it will speed the processing of the instruction. That means throughput will be increased. That is the case because multiple instructions are executed per unit time. So that means what? Throughput will be increased. Throughput will be increased there. And in superscalar processor, there are multiple functional units. So in the superscalar processor also, multiple functional units present, and each of which is implemented as a pipeline. Each of which will be implemented as a pipeline. So as a pipeline, it will be implemented. And each pipeline consists of multiple instruction at a time. That is what multiple instruction is getting executed in the multiple pipeline. So each pipeline will contain what? Each pipeline will contain multiple instruction at a time, which will support the parallel execution of the instruction. And superscalar processor are much faster than the scalar. That is, we have discussed, because it increases the throughput as the CPU can execute multiple instruction per clock cycle. So this is the all about our superscalar processor. So each and every processor you should keep in mind that they are different. Their working are different. So basically, for remembering this superscalar, remember that this superscalar processor is what it works on the scalar quantities or the scalar instruction to improve the performance of the execution of the scalar instruction. This superscalar works, and the main thing you should keep in mind that superscalar processor is what it works on the multiple instruction, or this multiple instructions will be executed. These have the multiple pipeline is present there. It will execute the multiple instruction. So if the multiple instruction is done, that means the number of instructions will be increased per unit time. So if that is the case, number of instruction per unit time increases, that means our throughput will be increased. This is the main thing you should keep in mind, and that means parallelly all of these instructions are getting executed. So this is the thing you should remember for the superscalar processor. Okay, clear till now? Anyone has any question? Anyone has any question? समझ में आया सबको?
Clear, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. So this is what? This is the superscalar processor. And the last processor we will see, that is the super pipelined processor. Now, super pipelined, from here you will see that the name suggests super pipeline. That means increase the speed of the pipeline. Increase the speed of the pipeline. So this is called as a super pipeline processor. And super pipeline processor is basically used to increase the speed of the pipeline. And it is what? It is an alternative approach for achieving the greater performance. For achieving the greater performance is referred to as the super pipelining. So it is the alternative approach for achieving the greater performance, referred to as the super pipelining. Now in super pipelining, processors many pipeline stages perform tasks that is required less than half a clock cycle. In super pipelining processor, many pipeline stage will perform tasks. In many pipeline stages are present that require less than half a clock cycle. Now, in normal pipelining, we have done that in each clock cycle, a stage is there. In each clock cycle, there is a stage, and that stage of instruction is executed in each clock cycle. But the difference in the super pipelining processor is what? Many pipeline stages are present there, and that pipeline stages to perform that require less than half a clock cycle. In the normal pipelining, one clock cycle is required, but super pipelining, we require only a half clock cycle. And super pipelined architecture is one that makes use of more and more small stages of pipeline in attempt to shorten the clock period with more stages. More instructions can be pipelined at the same time, which will increase the parallelism or the throughput. So super pipelining architecture is basically used for more and more small stages of pipeline, used for the more and more small stages of a pipeline to shorten the clock period, to short the clock period with more stages. Now we want that clock period will be shortened, and with this short clock period, and there will be more stages, clock period should be short, okay, but more stages will present there so that more instruction can be pipelined at the same time. So if we perform that more stages and more pipeline instructions in the pipeline at the same time, then it will increase the parallelism. That means multiple instructions will be executed parallelly. So if that is the case, then it will increase the parallelism or the throughput. So let's say in previously when there is normal pipeline, in normal pipeline, let's say there is a 3 instruction. Now 3 instructions will execute in 3 unit of time. 3 instructions will execute in 3 unit of time. That means each unit of time one instruction is get executed. But super pipelining does what? You see, we have said that super pipelining require half clock cycle. That means 3 instruction is executed 3 clock cycle. Let's say we say that in 3 clock cycle this is done. In 3 clock cycle the 3 instruction get executed. But in super pipelining, what is done? In super pipelining, 6 instructions will be executed in 3 clock cycle. That means each instruction will require then half amount of time. Half clock cycle it is required. That means from here you can see, if we shorten the clock cycle, then the number of instruction it is capable of executing more number of instruction if we short the clock cycle. So previously in 3 clock cycle 3 instruction get executed, but when we use the super pipelining architecture, in super pipelining 3 clock cycle 6 instruction get executed. So that means shorten the clock cycle. If we shorten the clock cycle, the number of instruction that. So here in the simple pipeline, if you see the first stage which we have, in the first stage we have total, we are considering the 5 stages here. We are considering 5 stages for instructions execution. Now first stage instruction 1 in the first clock cycle will do the instruction fetch. Then in the second clock cycle, the first instructions will start instruction decoding. And in that particular moment, the second instruction will do the instruction fetch there. will start the instruction fetch. So instruction decode and instruction 1 in this second clock cycle is decoding, and instruction 2 is what? Instruction 2 is doing the instruction fetch at this particular moment. Then in the third clock cycle, the instruction 1 is executing. Instruction 1 is executing. In that meantime, instruction 2 is what? It is doing the instruction decode. And latest is that the third instruction started execution in the third clock cycle. Then in the fourth clock cycle, the memory is used. The memory, it is used by the instruction 1. In this fourth clock cycle, it is what? The instruction 2 is executing, and this instruction 3 is doing what? It is performing the instruction decode. Then in the fifth clock cycle, it is completed. That means in fifth clock cycle, the instruction 1 is what? It completes its execution. That means here write back. So that means it is doing the write back into the memory. So in fifth clock cycle, it is done. It is completed. Then instruction 2 will do what? It will use the memory at that time. And instruction 3 will what? Instruction 3 is executing in that particular moment. Now in sixth clock cycle, already instruction 1 get completed. So there is no need. Already instruction 1 final execution completed. So there is no instruction 1 in this particular moment. No stages of instruction 1 is present there. Instruction 2, it using the write back. So now it is completed. And instruction 3 is doing the memory policy, memory write back in there. It is using the memory. Then in the seventh clock cycle, instruction 1 is not there. Instruction 2 already completes its execution. Only instruction 3 will do write back, and the final execution is done. So that means total 7 clock cycle period is required. 7 clock cycle period will be required for this execution of the 3 instruction if it is done in the simple pipelining. If we do it in the simple pipelining. But if we do it in the super pipelining, you see the change. We have done the changes in the super pipelining. That is what we have said, that each stage it requires half clock cycle. Each stage it requires half clock cycle. So that means, let's say that instruction 1, the instruction 1 is what? It is at first clock cycle, it is doing the instruction fetch. But you see, when this 0.5, that means when there is 0.5 in that stage, from there the next instruction 2's execution started. When the clock cycle is 0.5, when the clock cycle is 0.5, in that time, from there the next instruction started execution. So that's why it is like that. Then in the second clock cycle, instruction decode will perform. In the second clock cycle, the instruction 1 will perform the instruction decode. But from 1.5, the instruction 2's instruction decode will start. Instruction 2's instruction decode will start from 1.5. Okay, so it will continue up to where? 2.5. Now in this 1.5, that is what in this is 1.5. So that means instruction 3 will start execution. Instruction 3 will start execution when it is 1. But if it we have done in the simple pipelining, if we uses this in the simple pipelining, then we see the instruction 3's instruction fetch start from which clock cycle? Third clock cycle. But if we done it into the super pipelining, then in super pipelining, the instruction 3's instruction fetch after the first clock cycle. So instruction fetch start from here. Okay, so like this, you see 0.5. This is what the first instruction is, what? the first instruction is here in 5 clock cycle. This first instruction 1 get executed. Then from 0.5 it is started. So instruction fetch will be from 0.5 to 1.5 clock cycle. Then instruction decode will be from 1.5 to 2.5 instruction decode. Then execution will be from 2.5 through 3.5. Okay, for the instruction 2. Then from 3.5 to 4.5, this will be the memory, and from 4.5 to 5.5 the write back will happen, and the total instructions 2 will be decoded, completes its execution and the performance in the 5.5 clock cycle. And then instruction 3 start from 0.5 clock cycle from this. So this is from 0.5 to 1.5. So it will start from its 0.5. So that means 0.5 and 1.5. So it will start from 1. So that means after completing, this will be executed in total 6 clock cycle. So that means 1 clock cycle is less required. You see, that is the difference. That is the difference in the super pipelining processor, that it requires less number of clock cycle. Okay, it is clear to everyone?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
But the disadvantage, the advantage is that we require less number of clock cycle, and this less number of clock cycle, more number of instruction get executed. So this is the advantage. This is the advantage of using the super pipeline processor. But the disadvantage is also present, because it is not that some stages may require more number of time. Some stages it may require for execution, some stages requires more number of time. In that case, what will happen? Delay will occur. So if you remember, in the pipelining there is a problem delay. So if delay occurs, then that time this will be not, there will be not like this, that in half clock cycle it will perform. That some stages it may require much more time, some stages it may require less number of time. For execution of that stage, less number of time required, or some stages it may require more number of time. In that cases, this is the disadvantage of using the super pipelining processor. Okay, so this is all about our super pipeline processor. Now this is all type of processor we have seen, all type of processor. So from first, if we calculate that, first we have seen the VLIW processor, then our processor type of second type vector processor, then third type array processor, then superscalar processor, scalar processor, and this is the super pipeline processor. So this is all types of processor we have discussed. Now in the next class we will discuss about the cache coherence problem. The cache coherence problem we will discuss in the next class. So I will not start today. In the next class we will discuss about that cache coherence problem. Okay, so then thank you everyone. If you have any question, then ask, otherwise I will stop the session.
Sir,
सर
इंटरनल का सिलेबस कहाँ तक रहेगा?
हाँ,
सर इंटरनल का सिलेबस कहाँ तक रहेगा?
सिलेबस का इंटरनल का सिलेबस तुम्हारा जैसे हम जितना आज तक, आज हाँ, ये स्केलर प्रोसेसर तक, सुपर पाइपलाइन प्रोसेसर तक, ये वाला तक रहेगा. और सारा नोट्स देखो, हम तुम लोगों का जो है जितने तक है हम सारा नोट्स, आज का नोट्स हम दे देंगे, अभी तो ये करा है क्लास का है, तो आज का नोट्स भी हम अपलोड कर देंगे, बट ऑल द नोट्स आर विजिबल टू एवरीवन आई थिंक.
Yes, sir.
Okay. So then, thank you everyone.
Thank you, sir.
Thank you, sir.
Okay.